Okay. So first of all, how many types of threads is there? We have two types of threads, correct? One is user threads, the other one is daemon threads, right? So user threads means the threads which we are created by the user or in the application. We'll call them as a user threads. Okay, the threads whichever it is created by the JVM. Okay, JVM also will create some threads. Okay, but will not create that. JVM also will create some threads. Those threads will call it as a daemon threads. What is the purpose of, let's say we are writing some threads means there is some specific task is there to write off our threads, right? Then what is the purpose of JVM? Why it will create of threads internally? We'll call them as a daemon threads. There are some daemon threads also. So daemon thread will be used to, those are the background threads. First of all, those are background threads. Those will be created by JVM. The purpose of daemon threads is used mostly for to remove of garbage collections. Mostly for garbage collections, will use of daemon threads. What is mean by garbage collection means if any unused objects, let's say our application is creating of thousands of objects. So okay, so let's say the Facebook is an application. Lakhs of people will log into the application, and they can do of creating of comments, adding of friends, and then create uploading photos. Like that will do of lakhs of people will do simultaneously all the task, right? That time, so creating of object and removing of objects also should be there simultaneously. Okay, if once the object is created, if that object is not removed, then at some point of time we'll get off like out of memory, out of memory exception will get. So once the object usage is completed, then we need to remove the object. Then who is responsible to remove that object? We are not writing any code to remove the unused objects. So that responsibility is taken care by JVM. Internally, JVM will create of some daemon threads to remove of the unused code, to remove of unused codes, unused objects. Let's read it. Daemon threads are the threads which are mostly created by JVM. We will not create any daemon threads. If you want to create of daemon threads means whatever the user threads that we are created, we can convert them to daemon threads by calling of set daemon of true. Even user defined thread also will become as a daemon thread. Okay. Now, these threads always run in the background, and these are less priority threads. These are less priority. So, and these threads are used to perform background task like garbage collection. These threads are less priority threads. Why we will call it as a less priority means JVM will not wait for JVM will not wait for these threads to finish its work. Let's say daemon threads are running backgroundly. Just assume still their work is still daemon threads work is not finished. But JVM will not wait for those threads to finish its task. Okay, as soon as possible, whatever the user threads that is there. So once the user threads execution is finished, then JVM immediately it will exit that. Immediately it will come out of that main method or wherever it is. Okay, and there is a provision to convert user defined threads into daemon threads by using a method called set daemon of boolean type. If you are making as true means then that user defined thread will become as a daemon thread. Okay, now let's take it off one example. Okay, and you cannot set a daemon property after starting a thread. Okay, whatever that set daemon method we need to call before going to call off start method. If you are trying to if you are trying to convert that user defined thread into daemon thread once after starting of thread, then it will throw an exception called illegal thread state exception. It will throw that. Now let's see one example already. I will repeat it. Daemon test. Yeah. Let's yeah. Let's this is of one is user thread is there, another one is daemon thread is there. Okay, the work of daemon thread is I'm printing of 1,000 numbers. I'm printing of 1,000 numbers of the work of daemon thread is printing 1,000 numbers. The work of user thread is only print of 10 numbers. Okay, now even though the work of pending is there for the daemon thread, it's not finishing its work, JVM will not wait for that. Now let's run it, or else instead of keep it, not required this one. Already we are printing below, right? Now let's where we are using this one. Let's see, check off daemon test. Yeah, user thread start, thread, two threads. Let's keep it. Let's remove it. Daemon test. Daemon thread. Let me check off that. Daemon thread. Yeah. Get off daemon thread. He the thread for the new daemon thread. Now daemon thread dot on the thread user thread dot start. Okay. Now let's JVM. One span. Any errors? Not required. Now let's run it. I have started off daemon thread as well as normal user thread. Both I have started. Okay. Now daemon thread work is to print off 1,000 numbers, and user thread is only to print off message. Once user thread work is finished, then it will not wait for the daemon thread to finish off its execution. See, it is printed only of only 5. Okay. Let's this time if you're printing off once again, it may print off 6. Every time there is no guarantee like how many it will print it. There is no guarantee how many number of times it will iterate. Let's say if I am removing off, let's say if I am removing off this part, okay, if I am commenting this one or commenting off this line, then so it is not a daemon thread now. So it 100% it will execute of 1,000 iterations. 100% it will execute 1,000 times. Even daemon thread also. Is it clear, Imran? Yeah. Now, now today's next topic is so yesterday we have discussed creating of threads, okay, user threads, and uh, daemon threads as well as now let's go to what is the difference between user thread and daemon thread, and how to name a thread, okay, giving names to the threads, that also we have discussed yesterday. And default name of thread is like thread hyphen some integer number is the default name of the thread. If you are creating of 10 threads means thread hyphen 0, thread hyphen 1, thread hyphen 2, like that it will create the names of threads. Okay. And next is retrieving the name of the priority thread or main thread. So priority thread means main thread is like we'll call it as the main method will be run by JVM, right? For that also there is some name of the thread that is called as thread name is main. Okay, if you want we can change the name of the thread also by using of set name and set name to set the name. For getting the name of the thread means we can use of get name. Okay. Identifying a thread means if multiple threads are having same thread name, then in that case it is very difficult to identify which thread is executing currently. So to avoid that issue, so there is a one method called get id method is there. At the time of creating an object, at the time of creating of a thread, at the time of creating thread, so that time JVM will assign one unique long number to the thread. So that ID is unique for each and every thread. That id we can get by using get id method. Okay, that is of identifying a thread. Next, thread priorities. So let's say we have 10 threads is there. If you have 10 threads is there, who is going to execute all the threads? JVM will execute. So if one thread is currently executing, means rest of all threads will be in the waiting mode. Okay. Once, let's say thread 1 is executing right now, remaining thread 0 and rest of all threads are in the waiting mode. So once thread 1 is finished its work, then it will give chance to other 9 waiting threads. Two out of 9 waiting threads, the JVM will give chance to only one thread, right? So that is based on the priority of a thread. That priority will be decided by these three properties. Min priority is a 1, max priority is a 10, and normal priority is 5. Whichever having out of 9 threads, whichever thread is having max priority, whichever thread having max priority, that thread will be executed. That thread will get a chance to r- run it to start its work. Okay, next, how to set the priority? By default, the name of the thread, by default the thread priority is 5. That will call it as a normal priority. For every thread, default priority is 5. If you want to change the priority, then there is a method called set priority of the priority whichever you want to give, we need to give. But that priority must be 1 to 10 only. We can't give more than that. Okay, we can't give more than 10. If you want to get the priority, then there is a method called get priority method to return the thread priority. Okay, today this we have discussed. Now let's start off sleep method. Let's start off sleep method. Now, currently, let's assume we have two threads is there. Just assume two threads are running. Then, in that case, if I want to sleep my current thread as wait for or sleep for 1 second. If I want to sleep for my thread is sleeping for 1 second or stop its execution 1 second. Then, in that case, we can use of sleep method. Okay. So, what it will do? It will stop its execution. Whatever the currently executing thread, it will stop its execution. Okay, for a period of time. What is that period of time means? That period we can mention there are some overloaded methods. There are two overloaded methods is available inside sleep in the thread class with sleep of with seconds, sorry, milliseconds, sleep of with milliseconds plus nanoseconds. Let's take it off one example. Let's take it off sleep test, right? Let's control n, create one class sleep test. Okay, what we will do is we'll create of one class thread is already there. Yeah, extends thread. Okay, thread is already exist. Let's say keep of my thread. Even my thread 2 is also there. IBC thread, IBC thread 2. Okay, this is one thread, or else IBC thread. Okay. Let's override of run method. Override of run method. Now, what is our work is? Let's keep it up for loop just for some iteration. Just keep it up 10 times. So for every time, for each time it is iterating. Let's let's thread wait for 1 second or 2 seconds. Okay. System that out that print ln of I value is I I value is just print that I value and sleep the method. Okay, thread dot. There is a sleep method with milliseconds. Okay, what is the milliseconds for 1 second, guys? How many milliseconds for 1 second? 1000, right? So there may be a chance of throwing the interrupted exception. Let's say thread is waiting, thread is in sleeping mode. If some other thread is trying to call off, some other thread is trying to interrupt off the which is the thread which is in sleeping mode, then in that case it will throw an exception that is called as interrupted exception. So compulsory we need to keep this block in the try and catch only. We need to keep this block in try and catch. Okay, and then once it is work is completed, then it will continue again. It will come back in the running mode after this period of time. Okay, now this is the printing of one work. Just assume. Now let's call off this method. Okay, create object of method and create of what is the class? Create of object of this class and I just or ibc equal to new ibc thread. Now ibc dot start. Now let's see, it will for each time 2 seconds it will wait. See, for each iteration it is waiting 2 seconds, and at the time of sleeping time it will not give chance to any other thread. It will not give chance to any other thread also. See, it is done. Okay, so if you want to give off 2.5 seconds, what is the milliseconds for 1 second, guys? What is the milliseconds for 1 second? 1000, 10 lakh. That is yes. For what is the nanoseconds for 1 second? The nanoseconds for 1 second, guys. 10 lakh nanoseconds is equal to 1 second. Okay, 10 lakh nanoseconds is equal to 1 second. I'm giving of 5 lakhs 5 lakh nanoseconds. 5 lakh nanoseconds. Now let's see, it is of 2.5 seconds, right? Or else you can give as even one means it is of 1.5 seconds. Let's we can use of any one. See that? Every time it is waiting 1.5 second. Let's say if I'm giving 5. Okay, now let's see, it is of 5.5 seconds for each iteration. For each time it is 5.5 seconds it is waiting. See guys, whether it is running or not means still it is in red mode, means it is not terminated. Okay, still it is running only. So let's last two iteration and then it will go out, right? See, see, it is exited. Okay, if you want to stop off your current thread execution for a particular period of time, then we can use of a sleep method. Sleep method with two types is there. Overloader method, sleep method with millisecond with only milliseconds. Sleep method with milliseconds plus nanoseconds. Both we have discussed just now, right? So if you are giving 5000 milliseconds means it is a 5 seconds. 5000 milliseconds first 5 lakh nanoseconds is equal to 5.5 seconds. Okay, 5.5 seconds. Okay, this is of sleep method. Okay, and now moving to, there is let's say 2 to 3 threads are running execute running currently. Now I want to execute of the threads sequentially. I want to execute threads in the sequential manner, in the sequence manner. Let's say, let's go for we'll take off one more example. How to achieve, how to, let's say three threads are running. Okay, just assume three threads are running. So I want to execute three threads. Once first I want to finish off the execution of thread 1, and then it should give chance to thread 2, and then it should come chance to thread 3. Okay, so in this order only I want to execute. Then in that case we have a method called join method. We have method called join method is there to achieve the, to achieve the order of execution of a threads. Okay, now let's take it off one example. And inside by using join method we can achieve that order of execution of a threads. So even here also we have a, there are some overloaded methods is available. There are some joining a threads. Okay, join join method of a thread class is used to maintain the order of execution of a threads. I want to maintain some order of threads execution. Okay, then using join method you can make currently executing thread. Let's say T1 is started. I want to stop the T1 thread execution. Okay, I want to stop. I want to wait to give chance to some other threads to finish their work. Okay, now in that case we can use of join method. So join method is also contains overloaded methods. What is mean by overloaded method means in join name method, method name is same, but it will change the number of parameters or type of parameters will call it as a overloaded methods. Okay, now the join method is same. Okay, but the first join method doesn't have any parameter. Second method is it contains of milliseconds. Third method it contains of long milliseconds plus into nanoseconds. Both it contains. So it is of overloaded methods. By using of this, we can achieve that. So in this case, if you are calling of join method means until if let's say two threads is there, T1 dot join and T2 dot join. So those two will be, okay, those two will be until wait, if you are calling of T1 dot join and T2 dot join means T1 dot join, T2 dot join means T2 dot join will wait until it will go in the waiting mode, and then it will give chance to T1. Okay, if T1 is, there is no other task is pending, other threads are waiting, then T1 finish its task, and then it will come to T2 thread. It will give chance to T2 thread. Okay, but in case of you are calling of T1 dot join of some milliseconds means then whatever the mentioned period of time only, it will be in the waiting mode. After that it will come back in the running mode. It will not wait for to finish its work. It will wait only for the mentioned period of time only. Okay, that's what that. Now let's take it off one example. Let's take it off one example. Let's take it this one. Let's copy paste. I'll explain the code, guys. Okay, don't worry. Now let's mm, control class. What is the name, main method name? Thread 3. Finish. Okay. Yeah, now so in this class what I am doing, so I have created a class thread 1 class. I have created thread 1 and extending of thread. Okay, what is the purpose of thread 1 class is to print off to print off 0 to 10, to print off 0 to 10 the task of thread 1. So system.out.println what it will do, it will print once it is everything is printed 0 to 10 is printed, first thread task, first thread finished its task. Okay, now second second one is I've created one more thread. I've created of one more thread. What is the purpose of thread 2 is it is going to print of 11 to 20, and once it is printed 11 to 20, thread 2 task is also finished. Thread 3 thread 3 thread 3 task is 21 to 30 its task to print. Okay, let's say for example I have created of t threads, sorry, 3 threads, t1, t2, t3, all I have started created. Okay, t1 dot start, t2 dot start, okay, and t3 dot start. Okay, if I'm printing now, let's see how it is going to print. How it is going to print. See, is it printed in sequentially? What is my thread 1 task? 0 to 10. 3 is printed and it is giving chance to thread 2, and thread 2 is printed 11 to 19. 20 is pending again. Thread 2 is printed only 9, and then again it is giving chance to thread 1. It is printed of up to 10. Okay, and again it is giving chance to thread 2. 20 is printed, and see numbers from 0 to 10 is printed, and from first task is finished, and like that it is not giving in the order, right or not? So after finishing of a T3 thread, it is giving chance to print the message of T2 thread to give full message, right or not? Now, once the T1 thread is finished its task, printing from 0 to 10, and these lines will execute, right? After that, T2 has to start. It should print off 11 to 20, and then this message should come. Okay. Again, T3 has to start. 21 to 30 it has to print, and last it has to print off this message. Right. But that is not happening. But that is not happening if we are working, if you are starting 3 threads and started 3 threads simultaneously. Okay. Then in that case, we can use of join method to stop its execution, or it the thread which if you are calling of t1 dot join, t2 dot join, then the thread will be going into the waiting state. Okay, now t1 dot start, I have started t1 thread. Okay, and I am doing of t1 dot join. Okay, I'm calling of join method, add to try and catch, surround this method with try and catch. I said keep in waiting state. Okay, now t2 is started, and then even t2 dot join method. Okay, keep this also in the try and catch. Okay, next t3 dot join, even let's keep this also in the, if it is trying to executing of this one, if the chance is giving, JVM is giving chance to execute of T3 thread, then it is in waiting mode before it has to finish T2. And while executing of, if it is the chance is getting of T2, then it also will be in the waiting mode. So first it will give chance to T1 thread. Once it is finished its execution, okay, then it will give chance to T2. Once T2 is finished its execution, then it will give chance to T3 thread. Now let's see the output, how exactly it is going to print the data. Even that is giving chance to other threads, it will not. See what it is doing. First it is printed 0 to 10, and then it is printed. Numbers from 0 to 10 is printed, and the first thread task is finished. And 11 to 20, second thread task is finished. And next 21 to 30, third task is printed. Even though if you are running multiple times also, it doesn't matter. There is no change in the output. Even though if you are calling multiple times also, there is no change in the output. Okay, that's what, if you are giving some period of time, if you are giving some period of time, let's say I'm giving of half second, I'm giving half second for each. Okay, and then if within the half second, if it is completed its work, then no issue. See, within half second it is printing. Let's say I'll give off only 100 milliseconds. I think it can finish its task within milliseconds only. Within milliseconds it will finish. Let's I know that it will finish the work in within milliseconds only. Okay. Now let's give off even only 10 milliseconds. Okay. I'll give off 10 here. I'll give off even here also as 10. Okay. Even 10 milliseconds is also. This system is that much fast here, the processor. Okay. In that case, it can finish in the work within seconds, within milliseconds only it will finish its work. Okay. If you want to keep, yeah, this they have given provision to without if you are giving any seconds means milliseconds means it will wait until finishing of its task. Okay. Or else let's try for 1 2 or else 2002 3000, let's keep it P3. And this is of 2002, sorry 1001 to 2000. This is of 2000, right? 2001, and it is of 0 to 1000. Okay. Now let's see. So giving join method means directly until finish of its task, it won't give chance to other task. It won't give chance to other threads. In between, we can verify of that whether see after 500. See after 500, it is giving chance to other thread. It is giving chance to other thread. So what was done? It is waiting for 10 milliseconds, and then within that time the T1 is not finished its task. So it is giving chance to T2. T2. So T2 dot join means it will not until finishing of its task. It won't give any chance to others. Okay. Again in between see is of giving chance to again T1. So instead of whenever you are doing anything, so instead of giving up seconds, it is better to give up join method. So until finishing of its task, it won't give chance to any other thread. Okay. If you know that it can finish off its task within milliseconds, then you can mention that period of time inside join method. Okay. That's what this one join purpose. Okay. Is it clear, guys? What is the use of join? Yeah. Now next we'll go to synchronization. Next topic is synchronization. What is the use of synchronization? Okay, so purpose of synchronization is, let's say we are writing of some code, 2 to 3 threads we are created, right? Sorry, 2 to 3 threads we are created, but whenever it is executing one thread, okay, whenever it is executing one thread, so if you don't want to allow of other threads to execute, okay, there may be a chance, we have a concept called synchronization. If we are adding synchronized keyword to the methods, if you are adding synchronized keyword to the methods, then those methods, synchronized methods or blocks will be executed at a time only one thread until finishing of the thread work. It will not give chance to other thread. Okay. In bit sometimes in case of previously, in case of this one, what was happened? If you are giving of T1 dot start, T2 dot start, and T3 dot start means, so what it is doing, so it is giving chance first to T1 will execute of 10 nanoseconds, 10 milliseconds, just assume. So by the time it will print off 1 to 500, and it will give chance to, it may give chance to T3, and T3 will print off only 200, 2001 to 2200 only it is printed. Okay, like that, it is giving chance in between. But if you are using of synchronized keyword, if you are using synchronized keyword means, then in that case, once T1 is started its work, then it will not give chance to any other thread until its task is finishing. Everything is finishing, it will not give chance to execute of other threads. Okay, it is locking that, it is locking that thread. Okay, that method entirely it is locking, it is not giving chance to other threads, it will lock it. Okay, now let's go and we'll read off some points about that. Okay, and synchronized keyword is applicable only for the methods and blocks only, guys. Okay, synchronized is a keyword, it is applicable for methods and blocks. Methods means, let's take it off, one class sy and sync test. Let's say I'm writing of some void one method. I'm just assume I'm writing one method. Okay, so if this method is system dot out dot println enough, just yes, just print up some message. Okay, but if you are making, if I'm creating multiple times this class thread, if I'm creating multiple times this method, if I'm calling this method multiple times by multiple threads, okay, then in that case, it will give chance sometime to one thread for 1 second or nanoseconds, and some other time it will give chance to some other thread. So to avoid that, if you are making the this method as synchronized, if you are making this method as synchronized, then in that case, once any thread, either thread 1 or thread 2 or thread 3, once it is started by any thread, okay, then it will not give chance to execute of other threads. It will not give chance of to execute of any other threads. Okay, now we'll go for some example also, guys, soon. If a method or block declared as synchronized, then at a time, then at a time, only one thread is allowed to execute that method. Okay, even though we are calling multiple, created multiple threads and calling this method, but at a time, only one thread will allow to execute that. So until finishing of the task, it will not give chance to others. Okay, to execute that method or block on a given object, on a given object. We are creating object of this class and then calling up this method means, so it will give only one thread at a time to finish its task. The main advantage synchronized keyword is, so we can resolve data inconsistency problems. Okay, in case of previously, so thread 1 task is, actually thread 1 has to finish its full task by iterating 1000 times. But after 500 times it is iterating, it is come out of that and it is giving chance to T2, right? Right or not? So that will not happen if we are making the method as synchronized. Okay, that's what this point. Now, and if you are calling of multiple threads on the same method, then there may be a chance of inconsistent results also will come, will get, okay, will get of some irrelevant result also. Okay, and there is some disadvantages there if you are using of synchronizer means, so waiting time of threads will become it will increase. So 10 threads is executing at a time, only one thread is allowing, so rest of all 9 thread has to wait. So if it is if it is if you are not using synchronized, then in that case, all 10 threads can execute off at a time, right or not? But that is will not happen if we are using synchronized keyword for the methods. Okay, now, and hence there is no, so when do we need to go for if there is no specific requirement, if There is no specific requirement until unless don't choose the synchronization concept. Okay, it is of risky and it will increase the waiting time and there is some performance issues also will come. Okay, so it is very carefully we need to use synchronization concept in the applications. Okay, internally synchronization concept is implemented using lock concept. What is mean by lock? Lock means let's say for example guys, we are all in the hall, we are all in hall. Let's say one person is moved into some room and then he locked inside that. Okay, then until he's coming, the person who went inside the room, he's coming out of that with by locking unlocking the room. So until that some other person cannot enter into that room. Okay, if you are not locking the system, if you're not locking the door, just assume all 10 members is there, so 10 members also can be allowed to come into the room if you are not locking, right? The guy who's went inside, he's not locking means all is ready to move inside the room. If anyone is locked inside that, then only one person is allowed to go inside. Until that person is coming out, some other cannot enter. The same concept is here also. If any one thread is started executing of synchronized method means, then it will not give chance to any other thread to enter into that method. That's what the synchronization of that locking concept means. So once the thread is, the method which is synchronized method means the thread will lock on that object. On that method object, it will lock it. Okay, we'll see that example also guys soon. Okay, let's finish off this point. Every object in Java has a unique lock. Okay, every object has a unique lock. When that will come into the picture means, whenever we are using synchronization concept, then only the locking concept will come into the picture. Until that we will not get that. Okay, sorry. If a thread wants to execute, if a thread wants to execute any synchronized method on any given object, okay, first it has to get the lock on that object. Okay, if I want to execute of one method, if I want to execute of this method means, so on this class object we'll create of this class object and then we'll call of this method, right? So that time what it will do, thread will acquire the lock on this class object. Sync test class object will be locked by the thread. Okay, the thread will lock that object. So in that case, until finishing of the thread, okay, that lock will never release. Okay, now once the thread got lock of that object, then it's allowed to execute of then it starts its execution. Okay, if the synchronized method execution is finished, then automatically thread will release the its lock. Then the some other thread will get chance to start its work. Okay, we'll take off an example and then we'll see. While a thread executing any synchronized method, the remaining threads are not allowed to execute that method. That's what we are discussing. We'll discuss of one example. Okay, let's take it of this example and we'll r- explain that code. Okay, if sync test LCFTF. Yeah. First, there is a class called display class is there. So, and one method is greet method. The method is greet method and return type is void and it is taking of some name also. It's taking some name also, input name. And I'm iterating of 5 times. Okay, I'm iterating 5 times and I'm printing of each time one message congratulations, and it is waiting of 1 second every time. It is waiting of 1 second every time, and at the end we are printing of name. At the end we are printing of name. For each iteration this message will print and it will wait for 1 second and then it will print that name whichever you are passing. That like that 5 times it will iterate that loop. Okay, that's what the grid method work. Okay, now let's say create of one thread. I created class myThread. It is extending of a thread, and I am creating of a display class object. This is a class, right? I'm using of display class one variable, like string also one variable. Okay, display is also one variable, and string is also one variable. And I have created object of constructor of the class, and I am passing these two values. Okay, while creating object. Inside run method, I am calling of greet method. I'm calling of greet method. So I'll create of two objects. Now let's see, display class object I created first. We need to call that method, right? So and I created two threads, my thread one t1, same class my thread of a t2. First one, for both I am passing D object, same display object. Okay, D1 object only I'm passing for both the threads. Okay, now T1 is started, T2 is also started. Okay, now let's without this method. Now let's see how it is going to print the output. See, congratulations space, congratulations J. So like that, it is giving some irrelevant order. Now let's see if I'm giving as synchronized. Okay, I'm giving as a synchronized. So first, whether JThread or Sri SRI, Sri or J or Sri. So let's assume JThread is started. Then until finishing of JThread, congratulations J, congratulations J. Like that 5 times until it is printing, it is not giving chance to Sri. Now let's start it. So J is started. Until finishing of its 5 times, it will not give chance to Sri. So in this case, we can use of in this case, let's say 10 threads is there. 10 threads have started its work. Then any one thread is started this method. Then all 9 thread has to wait until finishing of the thread which is getting off lock of this display class object. Okay. Sometimes it can start off 3 also. Sometimes it can start off if the 3 is getting the chance. Then let's give chance to Sri, and let's see. See, first if Sri got lock, then it will not give chance to J until it is finishing its task. Or else, let's keep the message after this. System.out.println greet method finished. Finished its task by task with the name. Let me give of name. Okay. See, let's see. After 5 times, it will print this message. See, yeah, see, greet method finished its task with the name Sri, and then next it is giving chance to J. Okay. So this is what synchronization. Now let's see some some cases is there. Okay, let's see some cases. If we are not declaring, if you are not declaring greet, if you are not declaring greet method as synchronized, then both threads will be executed simultaneously and will get off irrelevant result, right or not? If I'm removing of the synchronized means, then it will get off irrelevant result. See, it's not we are getting off it is not correct way we are getting the output. Okay, now that's what this point case 1. Case 2, if sorry the greet method, if greet method has synchronized, then threads will be executed one by one until completing the first thread, second thread will wait. In this case, we'll get the regular output or we'll get of normal output. Okay, that's what the use of synchronized. Next, keep of case 3. Now, case 3 is if we are creating of what we are doing, we created of only one display object that we are passing to both the threads, right or not? Let's say if I am created one more thread, if I am created of one more thread and giving chance to other thread, then giving chance to other thread. Now let's see, are we getting regular output? Even in this case also it is giving of irregular output. So we are creating of different object. So the method of that greet method we are calling would be of same object, guys. If it is a different object means obviously it will go as a separate thread again. Can you utilize it? So we need to utilize of same object. We need to utilize of same one. Then only it will give chance to one thread at a time. If you are giving of multiple object creation, then there is no point of using this one. Okay. Now, even though we declare greet method as synchronized, but we'll get off irregular output. So in this case, because both threads are operating on different objects, this thread is operating on D1 object and the second thread is operating on D2 object. Okay, so in that case, we'll get off irrelevant result. Okay, next, class level lock. Till now, till now we discussed of till now we discussed of only the object level. We created object, right? Now we'll see of a class level lock. In this case, the object is we are making as object. We are passing to object. Now and that at that time the lock will be acquired on this object. And the time lock will be acquired on this object. Now when the class level lock will be acquired means for static methods, if the method is static, then in that case the lock will be acquired on class level, not object level. Now let's control Z, A2, control Z, synchronized static. Let's keep it as a static. Okay. Now, if it is a static method means, then in that case, static method lock will be acquired on class level, not object level. If the method is non-static means, then object will be acquired on object level. If the method is a static synchronized method, then the object will be acquired on class level, not on object level. Okay. Now let's go to class. Every class in the Java has unique lock. If a thread want to execute a static synchronized method, then it's required class level lock. Entire class will be locked. Before this, for non-static methods, only that particular object is locked. If you are creating a different class object again, if you are creating once again one more object, and then if you are passing to a different thread, then we are getting a irrelevant result again. Okay, if you want to log that class itself, then we'll make this method as static and then it is synchronized. Then if you are passing multiple threads for multiple objects also, the lock will be acquired on only first. Whichever it is locked, then that thread will not release the lock until it is finishing its task. Once the thread got the class level lock, means static synchronization methods, the meaning of that. Once thread got class level lock, then it is allowed to execute any static synchronized method of that class. Okay, static synchronized guys, not non-static synchronized. Static synchronized block, only one it will allow that. While a thread is executing any static synchronization method, then remaining threads are not allowed to execute any static synchronization method of that class. Okay, that is not possible. Only one it will allow that. But the remaining threads are allowed to execute of normal synchronized methods. Normal, this is of synchronized static method. Let's assume of there is some other method is there. Void one method. This is of normal method. Okay, but we can call off these methods on that object. That is possible. Okay, but static methods, static synchronized is not possible on the thread. Okay. Class level lock and object level lock both are different. There is no relationship between these two. Class level lock means entire class will be blocked, and object level lock means this is for this class will create a object. For this will create a object, and then that object will be utilized. Okay. If it is non-static means for each thread you are creating different object means then we'll get a irrelevant agent. Both are different objects. Okay. T1 is acquired the lock of D1 and T2 is acquired the lock of D2 object. Okay. If it is a static means both are static methods. It is a static method. Then both the threads, even though you are passing off different threads also, it doesn't matter. The lock is acquired on the class level. Okay. Now let's see synchronization block. Synchronization block. Now, till now, so we are making the entire class as till now we are making the entire class as synchronized. Okay, till now we are making entire class as synchronized. If you don't want that, then we can make a lines of code, whichever the lines of code you want to make as synchronized, then we can keep that code in the synchronized block. We can keep that code in synchronized block. How to means let's instead of making entire class as synchronized, then we can make there's then we can make a block of code. Okay, that's why in synchronized block, see, of this class object, synchronized of this. Control X 7 of static context, leave it. Okay. Yeah, this will call it as a, instead of making the entire method as a synchronized, I want to make this part as synchronized. I want to make only this line of code, I want to make it as a synchronized at a time. I don't want to allow to execute of only this line by multiple threads. Then in that case I can use of synchronized block. Okay, this will call it as a non-static block. This will call it as a static. We'll call it as a static block. Then this will call it as a synchronized block. Then we'll call it as a synchronized block. We are giving the name to this block. Okay. Now let's take it up. If you want, let's take off any example. Let's see. Yeah, if very few lines of code required for the synchronization, instead of making the entire method as synchronized, then only those few lines of code we can make them as synchronization. Then it will never recommended to declare the entire method as a synchronized method. Let's say in your method 100 lines of code is there. Okay, only 10 lines of code is you want to make as thread safe. Then in that case, instead of making the entire method as synchronized method, you can make the 10 lines of code as 10 lines of code as synchronized block. That is the best choice. Okay. Of code within the synchronized block. The main advantage of synchronized block over synchronized method is it reduces the waiting time of a thread. So the rest of the lines of code can be executed by multiple threads at a time. Only this block of code will be not executed by multiple threads at a time. So it is not stopping of executing of other lines of code, right? So if you want to make of a particular only some few lines of code as a thread safe or synchronization, if you want to make them as synchronized, then we can use of block in synchronized block instead of synchronized method. That's what this one. Okay, next part, you can try that example, guys. Okay. I'm giving up to get lock of current object. We can declare the synchronized block as synchronized of this. It will lock the current class object. Okay, it will lock that. Now to get the lock of particular object, to get off some particular object, then we need to give off synchronized of that class object. This means current class object. If you want to particular class object, you want to lock it, then we need to pass off that class object. Okay. And if you want to lock the class level lock, then we can pass off synchronized of that class name we need to pass. Then that entire class will be locked. See this example, this is of synchronized block example. I'm making, instead of making the method as synchronized, I am blocking this method here. Okay. This is what synchronization, guys. Okay. Next, tomorrow we'll discuss about deadlock. Tomorrow we are going to discuss about deadlock concept that I'll explain that tomorrow's morning. If you have any questions, guys, till now, I'll repeat it. Which are the part that you want in the synchronization or class level lock or in the sorry, or the join methods, joining a threads or sleep method. Any question, guys? Okay, if no doubt, then we can continue that class tomorrow. Yeah, thank you, guys. We'll meet tomorrow.